Do you want to learn how to configure VLANs in Mikrotik devices, specifically those from the families 100 and 200? In this video, I'm going to show you how to deploy VLANs in Mikrotik environments. Welcome to the network trip. Mikrotik devices have multiple ways for configuring VLANs. In this video, I'm going to talk about devices from the family Cloud Router Switch 100 and 200. Those devices have router OS on them. In this topology, I'm going to include a simple router. That device is going to be handling the inter-VLAN routing process. I'm including 3 VLANs, but the number can be any number that you want. So in this case, I'm using VLAN 10 for IT, VLAN 20 for marketing, and VLAN 99 for management. I will have 2 physical devices, CRS2XX, because I can't virtualize those specific models. And the configuration that we are going to apply is valid only for those particular models. Any device from the family CRS100 and 200. The main idea is that we need to configure trunk interfaces, and also we need to configure access interfaces. Trunk interfaces are the ones that are going to send traffic with VLAN headers. Access interfaces are interfaces that are mapped to a particular VLAN ID, but all the frames going out those interfaces are not going to include VLAN headers. So you can see here that we have the first switch. I'm going to name that S1. S1 will have 2 trunk interfaces. One interface that is connected to the router and the second interface that is connected to a second switch. In this case, the name for the switch will be S2. So I have 2 trunk interfaces on S1, and I will have multiple access interfaces. For the purpose of this lab, I will connect one computer to one of those access ports just to test connectivity inside that specific VLAN. So in this case, you can see that the red section here is for VLAN 10 and the blue section is for VLAN 20. The green one, VLAN 99, is for management only. That means that any endpoint connected to an access port won't be able to directly get access to manage the switch. In that way, we can apply security policies in this router. So we can include some firewall rules to allow traffic from the IPs that we trust. In phase 1, I need to configure the router. In that router, I need to add some VLAN interfaces in the port where S1 is connected. So I'm going directly to the Winbox in this moment, and I will add 1 VLAN interface per subnet. So this is the router that I have there. You can see if I go to interfaces, I have 1 LAN interface, and also I have a wireless interface that is actually my one connection for this example. My first step here is to add 3 VLAN interfaces, one for VLAN 10, one for VLAN 20, and the last one for VLAN 99. So I can do that easily going to interfaces, and then I need to look for the VLAN tab. So I will add a new interface here, and I will call that VLAN 10. And I will change the VLAN ID to 10, and that is going to be using as a master interface Ether4, the port that is connected to S1. Now I have 1 VLAN interface. I need 2 more. So I'm going to add a new one, in this case VLAN 20. VLAN ID is gonna be 20, and the master interface will be Ether4. Okay, and finally VLAN 99. VLAN ID 99, and my master interface again will be Ether4. So I have 3 virtual interfaces, so I can assign an IP address to every interface, and that IP address can be used as gateway for any device connected to that particular VLAN. I'm going to assign the first usable IP to every VLAN interface. So I'm going to IP, then address, and I will click on the plus button, and I will assign the IP 172.16.10.1/24 to VLAN 10. 172.16.20.1/24 to VLAN 20. And finally, I'm going to assign 172.16.99.1/24 to VLAN99. If we check the current configuration on interfaces, we can see that we have the master interface Ether4, and we have associated to it 3 VLAN interfaces, VLAN 10, 20, and 99. Now this device is working as a router on a stick. This is a very common way of configuring a router when working with small and medium environments. So we are ready with phase 1. In my next phase, I need to go to S1. And here I need to follow a very specific process. In this phase, I'm going to configure the first CRS200. I'm going to use a CRS212. So in this device there, I'm going to set the name S1 to it. This device has 2 trunk interfaces, one that is connected to the router and one interface that is connected to a second switch. So I need to identify those 2 interfaces, and also have many access ports. Some of them will be connected to VLAN 10 and some of them will be connected to VLAN 20. So I'm going to follow a 7-step process that I'm going to share with you. So the first step is just to create a bridge interface, and then I need to add all the ports to the bridge. So those are very straightforward steps that we are going to take now. Since I'm using a CRS212 that has a lot of SFP ports and only 1 gigabit Ethernet, instead of using Ethernet ports, I'm going to be using fiber ports. So in this case, instead of Ether2, this is going to be SFP2. Instead of Ether3, that will be SFP3, and so on and so forth. Step 1 is about adding a new bridge interface. So that is on bridge, then the first tab here, bridge, and then I can click on the add button. So I will set the name for that one, just bridge, and I will click OK. So step 1 is done. Step 2 is about adding all the ports that we are going to need in this topology. So you can see I have Ether1, so I will include Ether1 to the bridge. I need some additional ports, all the access ports, and also the second trunk link connected to the second switch. So I'm going to include all those ports. I'm starting with SFP2, then SFP3, 4, 5, and 6. But at this point, step 1 and 2 are done. So I'm going back to the process, and then we need to configure the ingress-vlan-translation tab. This step is related to the access ports. Remember that access ports are going to be sending out the frames without a VLAN tag. But when those interfaces are receiving frames, then the switch needs to add VLAN information. And that is exactly what we are going to do here. I'm going to the switch menu here, then to VLAN, and you can see that we have many tabs. So we're going to be focused on the tab number 3 here, that is ingress-vlan-translation. So I need 1 entry per VLAN. So I'm going to the topology as well. So I'm going to add 1 entry for VLAN 10. So remember here we are going to map the access ports only. So I have Ether 3 and 4. So in this case it will be SFP 3 and 4 mapped to VLAN 10. And also I'm going to have SFP 6 and 5 mapped to VLAN 20. So that's exactly what I'm going to do. So here we need to identify some important fields. The ones that we need to play with is new-customer-vid. So there is where we are going to add the VLAN ID. And also we need to add the customer VID. Since this is an access port, this value is going to be 0, since all the frames that we are expecting in that interface are going to be without a VLAN header. And additionally, we need to include every access port in that list. Starting with VLAN 10, so new customer VID will be VLAN 10 and the customer VID 0. So basically that's why this is called translation. The frames are coming without VLAN header, and then is going to be added a new VLAN header, VLAN 10. And additionally the ports, so in this case this is going to be SFP3 and also SFP4. So those are the access port for VLAN 10 on S1. Then I'm going to click OK. And I will do the same for VLAN 20. So in this case, new customer VID will be 20, the customer VID 0, and the ports mapped to VLAN 20 will be 6 and 5. So I'm going to select SFP 5 and SFP 6. And now I can click OK. So I have two entries, two groups of access ports. VLAN 99 doesn't require those entries since we don't have access ports for VLAN 99. So that's step number 3. So coming back to the 7-step process, so the next step is to configure the egress-vlan-tag. So the egress-vlan-tag is the second tab in the switch section. So in this case, we need an entry per VLAN, but here now we are going to include only the trunk interfaces. So you can see the pattern here. So in VLAN translation is for access ports and egress-vlan-tag is for trunk ports. So we are mapping the interface and the specific VLAN ID. So coming back to a CRS212 here, and I'm going to egress-vlan-tag. So in this topology, I only have two trunk interfaces, Ether 1 that is connected to the router and SFP2 that is connected to the second switch. So I'm going to add one entry per VLAN. So in this case, this is going to be VLAN 10. The tag ports are going to be Ether 1 and then SFP2. So I have that entry for VLAN 10. I'm going to copy that and I'm just going to change this to VLAN 20 and then to VLAN 99. I have one entry per VLAN and this has completed the step number 4. Next step is to create the VLAN table. So coming back to this device here, you can see that the first tab is VLAN. I'm going to add again one entry per VLAN. I'm going to start with VLAN 10. So I will include a new entry, vlan-id 10. So here in ports, this list is going to include all the active interfaces sending traffic for that particular VLAN. So in this case, all of them, access ports and also trunk ports. So I'm starting with Ether 1, this is one of the trunk ports, then SFP2, and then from 3 to 6. I will include all of them. Now I can click apply, and I will just copy this entry for VLAN 20. Now we can copy this, and I'm going with the VLAN for management. So the management VLAN needs to be sent only over trunk interfaces. So I will remove all the access interfaces like SFP4, 3, 6, and 5. And I will keep only the trunk ports, in this case Ether 1 and SFP2. Remember, the management VLAN only requires the trunk interfaces. We have completed the step number 5. Then we are going to the management interface. So we need to create a VLAN interface. We need to assign the VLAN ID 99. Then we can add an IP address. So in that way, we can have access to that device by IP. And finally, we need to update the VLAN table, since we need to allow access to that particular VLAN to the CPU in this device. So going back to the CRS212. So in this case, I'm going to start creating a management interface by going to VLAN, and I will add a new entry here, VLAN 99. The VLAN ID will be 99. In this case, the master interface will be the bridge. So I'm going to select bridge and I will click OK. So this is the interface that is intended for management. So I need to assign an IP address. If I see the topology here, you can see that the management network is 172.16.99.0/24. So .1 is being used in the router, so I will assign .2 to this device. So I'm going to IP, then addresses, and I will add a new entry here, 172.16.99.2/24. And I will select the VLAN 99, then OK. Since we are going to need access to this device from multiple networks, we can add a default route to get access to it. So we need the default gateway. Going to IP route, I can add a new entry, and my gateway will be the IP on the router 172.16.91.1, and we can press OK. So now we have one default route for this switch. The next step is to provide access to the CPU from the management VLAN. To do that, I need to go to switch and then to VLAN, and we need to update the entry for VLAN99. Simply we need to add the switch CPU to the list of ports. So you can see that entry switch 1-CPU. I'm going to select that, and then I will click OK. We are going to do the same in the next tab, the egress-vlan-tag. So we can go there and we can update the entry for VLAN99. We just need to add to the list of tag ports the switch 1-CPU. So at this point, we have added successfully the interface that we are going to use for management purposes. We can try the connectivity just by sending a ping to the IP on the router. That is 172.16.99.1. You can see that we have replied from that interface. That means that the traffic is being tagged correctly. So we can go back to the process here, and you can see that the step number 7, the last step, is actually the one that is going to enable all the configuration that we have performed at this point. And basically we need to enable the invalid VLAN filtering. The idea here is that if the switch receives traffic from VLANs that are not listed on the table, then it's going to drop that traffic. To complete the step number 7, I'm going to switch and then to settings. So I'm going to click here on settings, and you can see that the second tab is called VLAN. So the second option here is drop if invalid VLAN on ports. So basically we need to add all the ports, all the active ports. So in this case, we have Ether 1, SFP2, 3, 4, 5, and 6. And finally, I will click OK. After enabling that filter, if we are connected to one of the access interfaces, then we are going to lose direct access to that switch. So in my case, I'm connected now in the port SFP3. I'm gonna add one IP from that network to my PC, and then I will be able to successfully have communication with the router. In this moment, we don't have any security policies in that router. That means that the router by default is going to allow the communication between those 3 VLANs that we have implemented now. So we can have access to that device by using the IP 99.2 that is configured on S1. So I'm going to my network card here, and I will set an IP from the network for VLAN 10. So I'm going to IPv4, and I will change that IP to 172.16.10.50, for example. And my default gateway will be 172.16.10.1. I don't need a DNS server at this point. That means that at this point I must have connectivity with my default gateway. So I'm going to the command prompt here, and I will ping my default gateway 172.16.10.1. And you can see that I can successfully ping the router. To make this process easier, I'm going to add 2 DHCP servers on the router, one for VLAN 20 and one for VLAN 10. So I will open the Winbox and I will go directly to the router 172.16.10.1, and then I'm going to create 2 DHCP servers by going to IP, DHCP server, DHCP setup, and I will select VLAN 10. Will accept all the default configuration provided by the wizard, and then I'll do the same for VLAN 20. So you can see there I have 2 DHCP servers. That means that at this point I can go back to my network card here, and I will change the configuration from a static to DHCP for my card. So I'm going to IPv4, and I will change this to obtain an IP address automatically. This must take one IP from VLAN 10. I'm going to say IP config renew. This must take one IP from VLAN 10. You can see I have one IP 172.16.10.254. I have the default gateway, and I have ping to internet. So that's how I can test the connectivity for VLAN 10. So what happens if I move my PC from SFP3 to one of the access ports for VLAN 20? So I'm going to do that. I'm going to my rack here, and I will move the connection from SFP3 to SFP5. I'm back. I have moved the connection from SFP3 to 5. So I'm going to release the IP address that I have now, and then I will renew that IP. So if we check now, you can see that I have an IP from VLAN 20. So I have the IP 172.16.20.254. That means that the access ports are working well. I can test the connectivity by sending a ping to my default gateway, in this case 172.16.21, that's working. Also I can do the same for VLAN 10, that's working, and for the management VLAN 99.1. Remember, now I can have access directly to the switch. So that means that if I try to go to the Winbox and I scan here on neighbors, so you can see here that I can see that switch there, but if I try to get access to it, I can't do it. So that's impossible since we have a filter that is configured on that device. I must use the management IP. So if I use the 172.16.99.2, I can successfully get access to that switch. I'm going to change the identity here to S1. And now we are ready to go to the next one. Today we have learned this 7-step process for configuring Mikrotik switches from the families 100 and 200. Remember, this process applies only for those devices. This is the recommended approach from Mikrotik. In this way, we can take advantage of the switching process performed at a hardware level. If you have enjoyed this video, please like it, subscribe to the channel, enable the notifications. We are posting at least one video per week. I see you in the next one. Thank you.